Okay, welcome to another video of some optimizations. So in this example, they're giving us a window and they're saying the figure above shows the design of a window, which has a shape of a semicircle attached to a rectangle. The diameter of the semicircle is 2x, so obviously that's the 2x bit there. And it's attached to a rectangle also measuring 2x. And the other side of the rectangle is y, that's the y. And the perimeter, so going all around, is going to be 6 meters. Now in this question, it's very structured, so they're asking us show that the area of the window is given by this, and then the next question, the follow-up question is, hey, work out the x value where the area is the maximum. Now usually in an exam, they're not going to give it so nicely and structured for you, so they'll just say, hey, what's the maximum area? And there's a couple of steps that you'll need to follow. The first thing that I always look for is the information they give me regarding the restriction. So I call it the restriction because the perimeter of this window is 6 meters, and that's kind of restricting the size. In different examples, they might say the area is this or the volume is this. So we know we're going to write some kind of an equation using that. So I'm going to start off with that because that's the easiest bit. And that's given. So the perimeter of this would be obviously y plus y is 2y and 2x. So that's the sides. So let's write 2y plus 2x. And then this is a semicircle. So a normal circle would be 2 pi r, but this would be divided by 2. So those would cancel out or reduce to 1, and then it will just be pi r. And to make my life easier, I know that from here to here is the diameter of the circle. So the diameter of the circle is 2x, so the radius is just going to be x. So instead of writing the r, I'm just going to write an x. So now I have everything in terms of x and r, and I know this is going to be 6 meters. So now I can write y in terms of x, and that will always be kind of step one is writing one thing in terms of the other variable. The other option here, or the other thing we need to do is we have to write the area. So I'll just write the area formula here. So I know the area is going to be length times width, which would just be 2x times y. So 2x times y is just 2xy. And then pi r squared is a full circle, so this will be half pi r squared, or pi r squared divided by 2. But I know that the radius is x, so I'm just going to write an x from the beginning. Now, in order to find the optimum area, obviously I'll need to derive this. But I can't derive this because I have two different variables. And this is where this is kind of important for me, because now I know the 2y, I can sub the 2y in here. I'll rewrite this so it looks 2yx. I got kind of lucky with the variables in this case. Sorry, just out of habit writing r. So the 2y and the 2y is going to be the same. If they didn't give me, if there wasn't a 2y in here and just a y, then I'll just divide everything here by 2. But now, since it's very convenient, I'm just going to do 6 minus 2x minus pi x. There we go. And I'm going to sub in this part in here. Let's do it nicely color-coded. So, oh no, wait. The 2y, I'm going to write the x in front. And then x times the 2y, which would be 6 minus 2x minus pi x. And then plus the pi x squared. And now I'm just going to multiply or expand the brackets. So I have 6x minus 2x squared minus pi x squared plus half pi x squared. And these are like terms, x or pi x squared and pi x squared. So I'm going to be left with 6x minus 2x squared, and minus 1 plus a half will just be minus a half pi x squared. And I can see I can figure this out. 6x minus 2x. So yay, we got that right. But yeah, simple enough. So the next part of the question is they're asking us, let me just read it here. Got a little paper here. It says find the value of x, which a will be the maximum, and show indeed that it is the maximum. I'm going to rewrite this on the side because this is the important formula that I need to derive. Or do I have enough space? I'm just going to derive it here. So in order to find a maximum value, or a minimum. Well, basically I need to find a stationary point. I'm going to have to derive this, and now this is possible to derive because I have a in terms of x, so I can derive a with respect to x and just derive this. So 6x, that will just be 6, and then 2 times that's minus 4x, and then 2 times a half conveniently just becomes a negative pi x. Okay, and that's pretty simple enough. Because I want a stationary point, this is going to be equal to 0. And now I just need to find x. So I'm going to put, let's say I'll put 6 equal to 4x plus pi x. And I'm going to factorize an x out of there. So 6 is going to be x 4 plus pi. And then I'll just divide by 4 plus pi. So x is going to be 6 over 4 plus pi, which is a number, if I work it out, it's going to be 0.84 meters. So that is the value for the x. And to find out whether this is going to be, I can work out the area, obviously, if I wanted to sub the x. Did they ask find the value of x? No, they only asked for find the value of x. But if they wanted the maximum area, I would take this number and I'll just sub it into all those x places, and then I'll have the maximum area. In this case, they just want me to prove that it's a maximum. So then I need to get to the second derivative, which is easy. I'm just going to kind of take all of this away and just derive d2a dx squared is going to be, what's that, just negative 4 negative pi, which is just, this is going to be always going to be a negative number. So I usually write a little negative parabola for myself, and I know, well, if this is a negative shape, then this is going to be a maximum point. So it's a maximum because the second derivative is a negative value. Okay, on to our next question. So in this question, they're giving us a cylindrical, or they're saying a manufacturer produced pain relieving tablets, and each tablet is in the shape of a solid circular cylinder with a radius of x and a height of h, and the volume for each tablet is 60 cubic millimeters. If this was, well, this is a nice and structured question. So the first one is saying express h in terms of x, and the next one, there obviously you can't see this now, but it says show that the surface area of A is given by a certain formula, like A is equal to something, something, something. We'll look at that now, and then later they're saying find the value of x, which A is the minimum. So nice and structured for us. In an exam, it'll not be structured. They'll just say, hey, find here's the volume, find the area. So I'm going to start off with the part they give me here, and this is the volume. And I know that the volume is given by, let's say the base would be, let's just write volume is the base, which is pi r squared. And in this case, it's actually pi x squared. So I'll change that now. And times the height. So I know 60 is going to be pi x squared because the radius is x times height. And they're saying express h in terms of x. So h is just going to be 60 divided by pi x squared. So that's kind of nice and simple. And this is the first start. And all of these questions are going to have some kind of a restriction or something like a volume or a length or an area, and then that will enable us to write one thing in terms of another thing. And then next we're going to find out what the surface area is. So let's do a different color just because we want to be funny. And we say area is going to be, so how will I find the area of this? Well, there are two circles, so top and bottom, so 2 pi r squared for top and bottom. And then plus the cylinder would be the diameter of the cylinder, or not the, the circumference of the cylinder, which would be 2 pi r. We'll change the r's into x's now. So it's that part, and then times the height, because that's just a rectangle, 2 pi r times the height. And I'm just going to sub in my x's, so 2 pi x squared plus 2 pi x h. And in this case, I know h I can sub in there because in the end I want this formula and I want to have A in terms or area in terms of X, or if X was called R still, it would be area in terms of R. I don't want area in terms of X and H. So that's kind of the endpoint we have here. So now I'll just put in my 2 pi x squared, that didn't change, and the 2 pi x is just going to look like that, and then I'm going to put in 60 over pi x squared. So the 2 times the 60, oh, let's just write this again. My pi's aren't looking great, but anyway. The 2 times the 60, that's not an equal sign, plus sign, is going to be 120. And this x squared and that x would cancel out. The pi's would also cancel out. So I'm basically just left with an x underneath. And this is what the question said. They say to show that area is given by the formula A is equal to 2 pi x squared plus 120 over x. And there we go. Pretty simple enough. And the next part of the question is find the value of x, which A is a minimum. So now we basically just have to derive, and I'm going to rewrite this so that it's just a little bit easier to derive. A is equal to 2, let's try better, pi x squared plus 120x to the power of -1. And I'm going to derive it here. So dA, change in A with respect to x, is going to be, that's going to give me a 4. And then pi x, and that's minus 120x to the power of -2. And this would all be equal to 0, because I want to find a stationary point, and the stationary would all either be a minimum or maximum point in this case. But I know it's a minimum because the question said, hey, prove it's a minimum or show that it's a minimum. Okay, so we have that. It looks a bit weird here. You can maybe rewrite it like this. I know we don't like fractions, but once I rewrite it like this, I can see, well, to get the fraction away, I'll have to multiply by x squared. So 4 pi x cubed minus 120 is 0. And now I can see, well, this should probably just be easy. So 4 pi x cubed is going to be 120. I'm going to divide both sides by 4 pi. So x cubed is going to be 120 divided by 4 pi. And then I'm just going to take the cube root on both sides, and then x would be equal to, if you put in your calculator, it's just going to be 2.12. Okay, that was simple enough. The next example is not structured. So let's take a look at what they're asking us here. I have it right over here. Let me just take this away. No problem. Now the next one isn't structured, so we're kind of left on our own. So there's kind of two things that we're going to do. We're going to write probably two formulas, one for volume, one for something else. I'm not really sure. We'll take a look at what the question asks now. So let's say there's a solid brick, and let's draw a little brick. It's like, what is orange and bad for your teeth? A brick. Yeah. Ha ha ha. Anyway, so measuring 5x by x by h. So maybe the height is h, and maybe that's 5x, and maybe this is x. So this is my cuboid. And they say the surface area, just area would be nice, surface area is 720. Wow, what a surprise that they're giving us some kind of information about it. So either surface area or something. And they say, hey, calculate the maximum volume. So I'm going to start with this surface area, because that's the part that I know. I'm going to use that part. So the surface area I can get by, this is x times h, but there's two of them. So it's going to be 2xh. And then this side would be 5x by h, but there's also two of them. 2 times 5x. Let's just make it easy. 5x by h. Plus, and then the top is x times 5x, but the two of them as well. And that would be 2 times 5x squared. And I know the surface area is 720 is going to be, well, let's make let's make life easier and just divide by 2 all around. So 720 divided by 2 is giving me 360. I'm just making my life a little bit simpler. And then this is going to be xh, that's going to be 5xh, and that's going to be 5x squared. So, what do I want? I'm not really sure now if I want x in terms of y or y in terms of x. So I'm going to kind of pause that, just put a pin in it. And I'm going to write the volume. So the volume, I know this is the equation that I'll have to derive, because if I derive this equation, I can equal it to 0 and then find a minimum maximum point, and that's how I'll find the maximum value. So to find the volume, it's just going to be x times 5x times h would just be 5x squared h. So if I look at this, I think it's probably going to be easier for me to sub in the h, because I'm not really looking, I see there's a couple of terms here. I'm not really looking forward to doing x squared. It doesn't matter. I can write h in terms of x or x in terms of h and sub it in, and both will work. The one will just be a little bit more headache than the other one. But let's do h in this case. So this is 5, I think. I'm thinking now, did I make a mistake here? No, it doesn't seem like it. We have 5x and 5x. Okay, so that's fine. 360 is going to be 6xh plus 5x squared. So this can be 360 minus 5x squared is going to be 6xh. And then I will just divide both sides by 6x. So h is going to be 360 minus 5x squared all over 6x. Okay, cool. If I didn't divide by 2, maybe you could follow that route and you would have said, well, this is 10xh plus 10x squared. You would have had 720 here, and yeah, you would have ended up with h is equal to 720 minus 10x squared all over 12x. It's the same thing, it's just a little bit reduced now. But I'm just going to sub this in here. Let's do a different, just mixing the colors up. So 5x squared, and in h's place, I'm just putting this thing, so 360 minus 5x squared all over 6x. And now I'll just have to multiply. So this x is going to just take that x away. And I'm going to... I think it's easier to... Let me rewrite this just to make it a little bit easier. I'm going to write it as 360 over 6 minus 5x squared over 6. So I cancel the reduce to 1 this x squared, so now it's not x squared, it's x, and that x is missing, and I just split it in 2 just to make the multiplying out easier. I can do it, I promise, but I know it's just easier to explain this way. So now I'm just going to multiply 5 times 360 and divide by 6, so 5 times 360 divided by 6, and that gives me 300 x, pretty simple. And then here I'm going to have 5 times 5, which is, well, I have to minus 5 times 5 is 25. X times x squared is x to the power of 3, and that's over 6. So that's pretty much it. Let's just keep it as, I'm going to rewrite it as 300x minus 25 over 6x cubed, because it's just a little bit easier to derive. But anyway, so that's kind of where I needed to be at. Okay, so I need to just do, well, okay, let's just stop there and say, okay, this is my volume equation now. So I have volume in terms of x. In order to find a maximum volume, I need to find a stationary point, and therefore I'm going to derive this. So dv over dx is going to be 300. And here 3 is going to be multiplied with the 6, so that's going to be a 2. So it's going to be minus 25 over 2, and then that reduces by 1, so x squared. So this is now my derived formula. This is going to be equal to 0. And now I could multiply by 2 to make my life maybe a little bit easier. So this will be 600 minus 25x squared is equal to 0. So 25x squared is going to be 600. So basically I moved that over, switched it around. And then x squared is going to be 600 divided by 25 should be 12. Well, I'll just check. Wait, 600. No. Divided by 25. Oh, it's 24, obviously. Okay, so that's 24. And then last but not least, we can find x is then the square root of 24. Or it can be written as a surd like this, or it can be it's 4.8989, whatever, but we can maybe round to there. We're only taking the positive value here because it's positive. Usually when we work with area and volume and things like this, we're not going to take the negative value because I can't measure negative values. Okay, so it's positive distance. But they said calculate the maximum value of the volume of the brick. So now I just have to take this number and I have to sub it in there. So that's just a basic calculator trick. And once you've done that and put that in your calculator, you get a number like 979.80, and our units are cubic. No? Yeah, it is volume, cubic centimeters.